Hello, this is Pat Kelly. Okay, this is a good problem, right? I mean, they give us the solution, they give us the answer. Of course, if you check the directions, we're supposed to verify that this is a solution to this differential equation. And I think they also want us to grab a graphing utility, get that handy, and then to plot several of these solutions, several of these particular solutions for some values of C1 and C2, okay? So, to start, if we're going to verify that this is indeed a solution to the differential equation, it's mostly just a substitution game and see if you get balance, see if things equal at the end. So the substitutions that I need to make, as you can see in the differential equation, I have a y, which I would just substitute that in, but I'm also looking ahead and seeing that I'm going to need to substitute for y prime and even y double prime. So the work we need to do to begin is to find y and y prime and y double prime. Y is staring at me, but if you don't mind, I'm going to take it a step further and distribute the parentheses. I just see that as being easier for my y prime and y double prime. So I'll distribute through this e to the minus 3x power. And I'm just looking at C1 times e raised to the minus 3x power plus C2x e raised to the minus 3x power. Okay, good. Moving on, we also know that we need a y prime when we go to do our substituting. So I just want to differentiate this expression with respect to x. Okay, so differentiating this first term, a minus 3 would come out of that exponent when we differentiate. You still have your C1. And the derivative of these exponentials always just spit themselves back out, right? So you still have that. Plus, and when I move on to my derivative of the second term, just be careful. There is a product rule in there, okay? So when I go to do the derivative of the first, the derivative of x is just 1. I'd still have C sub 2 e raised to the minus 3x power, plus, as part of the product rule, leave the first alone, that would be my C2x, and multiply by the derivative of this second guy. So you're actually going to have a minus 3 come out there, and then multiply by the C2x, and you still have your e raised to the minus 3x power. Okay, there's my first derivative that I'll be ready to substitute. Now I need my second derivative. So I'll differentiate this expression. And I'm just looking right here and going right down the lines. So minus 9, 3 times 3, C1, that actually is a positive, right? Minus, C1, e raised to the minus 3x. What I like to say is be careful of all those negatives, right? I should listen to myself. And then this minus 3 comes out, and that would multiply by the C sub 2 e raised to the minus 3x. Okay, now when I go to do the derivative of this, it's another product rule. Let's be careful with that. First, I would leave the x alone. I would take the derivative of the x and leave the second alone. So the derivative of x is just 1. I'd be looking at minus 3c sub 2 e raised to the minus 3x. And then plus, plus, now I'm doing the derivative of the second, so the minus 3 would come out in front, and there is a minus 3, so that'll be plus 9 c sub 2, and the x is still there. That's me leaving that alone, and the derivative of this guy still has itself in there, and I'm looking at that. Okay? All right, there's my derivatives, and there, if I look back at my differential equation, there are my 3 pieces of the puzzle that I need to plug in. If we're going to verify that this is a solution, I'm going to do my substituting and see if we do get balance. In other words, see if we do equal the 0 that we're supposed to equal. Okay, so my y double prime, I have in pink here even, That's all right here. I'll just rewrite down below 9c sub 1 e raised to the minus 3x. As I'm doing this, notice there's minus 3c2 e to the minus 3x minus another 3c2, so that's minus 6c2 e to the minus 3x, and then plus 9c2x e to the minus 3x. Okay, now I'm looking back up here. I've got plus. Maybe I'll even switch colors for the plus. But then there's a 6 I'll keep in yellow. But I'm multiplying by the y single prime that I have in my orange. So now I'm putting in everything from my first derivative, minus 3c1 e raised to the minus 3x plus c2 e raised to the minus 3x, and then minus 3 c2 x e raised to the minus 3x. And I'm going to try to be careful to close parentheses there, because it's all being multiplied by the 6. And I got to go down a line, but I'm actually still continuing. If I had more room, I'd go over. Next, I'm looking at plus. There's a 9 as part of the differential equation. And then the y that I have in green, I'll start parentheses up here again. That would be all of this. So c1 e raised to the minus 3x plus c sub 2 x e raised to the minus 3x, close parentheses, and back to the original equation, equals 0, but that's actually a question mark for us. If we're going to verify that this is a solution, it will be a solution if the answer to that question is yes. Okay, so let's see what we've got. Excuse me. I'll go down another line here and try to combine like terms. Okay, and I think to make it the most clear, I'm going to go one more step here and distribute through these parentheses, because then you're going to see the like terms lining up really well. Okay, so let me go down and rewrite from here, just distributing through parentheses. 9c1 e minus 3x minus 6 c2 e minus 3x plus 9 c2 x e raised to the minus 3x minus 18 c1 e raised to the minus 3x, distributing through the 6 plus 6 c2, where I'm at, and then e raised to the minus 3x, distributing through the 6 still, minus 18 c sub 2 x e minus 3x. Come down here and distribute through this 9 c1 e raised to the minus 3x plus 9 c sub 2 x e raised to the minus 3x. Phew, and we still have that question of does that equal 0? But I tried to suggest our like terms, if we combine like terms now, would be kind of easy to see. Here's 9c1 e to the minus 3x, and here's another 9c1 e to the minus 3x. That's 18 of them. And Here's minus 18c1 e to the 3x. Those all go to 0. Let me do this term next, minus 6c2 e to the minus 3x. And if we look at our other c2s, there's a positive 6, and that's all of them, so that goes to 0. And then I'm looking at 9c2x e to the minus 3x, and here's 9 more of them, exactly the same factors, so like terms, that goes up to 18, and here's a minus 18. Okay, so we get 0 equals 0. Whew, a lot of work, but confirmed. Verify that this is a solution to this differential equation. Okay, that's great. We still have a little bit more to do. They asked us to grab a graphing utility and to graph several of these solutions, particular solutions though, just by picking some values of C1 and C2. Okay, so I'll grab my graphing utility. And all we're doing, I mean, you can do different values of C than I am, but I'm looking at this original solution and I'm picking my own values of C1 and C2. So if you want to do exactly like I'm doing, for y sub 1, I'll start with parentheses. I'll just pick a 1 plus maybe 2. And then don't forget to multiply by an x, close parentheses, e raised to the negative 3x, close those parentheses, and now we'll move down to my y sub 2. So we would like to see more than one of these solutions on the same set of axes. Pick different values of C1 and C2. If you want to do the same as I'm doing, I'll start parentheses, maybe a 3 plus 8x, close parentheses, e raised to the negative 3x, close. And I'm going to go one more in my y sub 3, because you are allowed to throw in even negatives if you want. Okay, so I'll start parentheses, maybe I'll do a positive 5, but then subtract 30, I don't know, times x, close parentheses, times e raised to the minus 3x, close parentheses, do more if you want, but I'm going to hit graph. It takes the calculator, it takes the utility, depending what you're using, a little bit of time to graph these. And the whole point of graphing a family of these solutions on the same set of axes is you want to see what similar behaviors the different curves have. So you can see a little bit going on. I'm going to zoom in once. You're welcome to do the same, because I see that my first two versions of this solution go up and then come down and hug the x-axis. And the third one's coming from up above. That's when I threw some negatives in there. But it's got the shared behavior of hugging that x-axis as it shoots out to the right. Okay, so that's relevant. Okay, all right, a bit of work. Practice some more on your own. I know you'll do well.